Hello students, welcome to my YouTube channel and welcome to the topic of integration. In this particular video session, just we are going to discuss about the problems of number 2 of exercise 9b. In the previous video session, just we have discussed about all of the problems of number 1 of exercise 9b. So let us go through the first bit of number 2. First bit of number 2, it is given that integral of the multiplication of sin x and cos x with respect to x. We can solve this problem in 3 methods and we will get 3 different answers for this one problem. Let sin x is equal to t, cos x dx is equal to dt. So in place of sin x we have to put t, in place of cos x dx it is dt. So it will be t square divided by 2 plus any constant. In place of t, we have to put sin x, so it will be in the form of sin square x divided by 2 plus c. It is the method number 1. Then let us go through the second method. Another method, we can express it in the form of cos x multiplied with sin x dx, and here let us consider cos x as t, so minus sin x dx it will be dt, that means sin x dx it is minus dt. In place of cos x we have to put t, in place of sin x dx it is minus dt, so it will be minus multiplied with t dt, minus t square divided by 2 plus any constant c, minus in place of t we can put cos x, so it will be in the form of minus cos square x divided by 2 plus any constant c. It is another method. Then let us go through the third method for this problem. Let us divide and multiply the given integral by 2. First of all, let us divide it by 2 and then multiplying it by 2, we have in place of 2 sin x cos x, we can put sin 2x. Then let us consider 2x as t, that means 2 dx is equal to dt, that means dx is equal to dt by 2. So it will be 1 by 2 integral of sin t dt by 2. It is 1 by 4 integral of sin t dt. 1 by 4 integral of sin t dt, it is minus cos t plus c. So it will be minus 1 by 4 cos, in place of t we can put 2x plus c. So it is minus 1 by 4 cos 2x plus c. Then let us go through the second bit of number 2. Integral of tan qx multiplied with sec square x dx. Derivative of tan x, it is sec square x. So let us consider, let tan x is equal to t, that implies sec square x dx, it is dt. So it will be tq dt, that implies t to the power of 4 divided by 4 plus c. In place of t again we have to put tan x, so it is tan to the power 4x divided by 4 plus any constant c. So this is the solution for the second bit of number 2. Then let us go through the third bit. Integral of cos x square x divided by 1 plus cot x dx. Let 1 plus cot x as t, then it will be minus cosec square x dx, it is dt. That implies cosec square x dx, it is minus dt. Integral of 1 upon t, in place of cosec square dx, we can write down minus dt, then it will be in the form minus multiplied with the integral of 1 by t dt. Integral of 1 upon t with respect to t, it is ln modulus of t plus c minus ln modulus of, in place of t, we have to write down 1 plus cot x plus c. So this is the solution for the third bit of number 2. Then fourth bit. Fourth bit, integral of sin x divided by cos qx dx. It will be in the form of sin x divided by cos x multiplied with 1 upon cos square x. Just I have expressed cos qx as the multiplication of cos x with cos square x. Then it will be in the form of tan x into sec square x dx. Let tan x is equal to t, then sec square x dx, it is dt. So it is t dt. Integral of t with respect to t, it is t square divided by 2 plus c. That implies 1 by 2 tan square x plus c. And this is the solution for the, this is the answer for the fourth bit of number 2. Then let us go through the fifth bit. Before going to the fifth bit of number 2, let us solve the fourth bit of number 2 in another method. So again, let us go through the fourth bit. Integral of sin x divided by cos qx dx. It will be in the form of 1 upon cos x, 1 upon cos x multiplied with sin x divided by cos x. 1 upon cos x, it is sec x, then it is sec x tan x dx. Let us consider this sec x as t. Let sec x is t, then derivative of sec x, it is sec x into tan x with dx, it is dt. That means this part is dt and here sec x is equal to t. So it will be t dt. Integral of t, it is t square divided by 2 plus c. So it will be 1 by 2. In place of t, we can write down sec x. So it will be 1 by 2 multiplied with sec square x plus c. And this is the solution for the fourth bit of number 2. Then let us go through the fifth bit. Then let us consider, here in this problem, let us consider sin x as t. Let sin x as t, then its derivative cos x dx, it is dt. So it will be 1 upon t to the power 5 cos x dx, it is dt. T to the power minus 5 dt. So it will be t to the power minus 4 divided by minus 4 plus c. So it will be minus 1 upon 4. T to the power minus 4 is shifted towards the denominator part, so it will be minus 1 upon 4 t to the power 4 plus c minus 4 into, in place of t we have to write down sin x, so it will be sin to the power 4x plus c. Then it will be minus 1 by 4. We know that 1 by sin x, it is cosec x. So 1 by sin to the power 4x, it is cosec to the power 4x. So it will be cosec to the power 4x plus c. Then let us go through the sixth bit of number 2. Sixth bit, cosec square ln x whole divided by x dx. So it will be cosec square ln x multiplied with 1 upon x dx. Let us consider ln x as z, then it will be 1 by x dx, it is dz. Cosec square z 1 upon x dx, it is dz. Integral of cosec square z with respect to z, it is minus cot z plus c. So it will be minus cot, in place of z we can write down ln x, minus cot ln x plus c. So this is the answer for the sixth bit of number 2. Then let us go through the last bit of number 2, seventh bit. Seventh bit, integral of square root of 1 minus sin x multiplied with cos x dx. Then let us consider 1 minus sin x as t. So minus cos x dx, it is dt. Then cos x dx will be minus dt. Cos x dx, it is minus dt. Then by putting these values here, it is square root of t minus dt. Then it will be minus t to the power 1 by 2 dt. Integral of t to the power 1 by 2, it is t to the power 3 by 2 divided by 3 by 2 plus c. Then it is minus 2 by 3. In place of t, we can write down 1 minus sin x. So 1 minus sin x whole to the power 3 by 2 plus c. So this is the required answer for the number 2. So particularly in this video session, just we have discussed about all of the bits of number 2 of exercise 9b. In the next video session, just we are going to discuss about the problems of number 3 of exercise 9b. Till then, thank you.